Hi ladies and gentlemen, today we're going to be going over the part-to-part ratio word problems in the practice section. So let's get started with number 1. The ratio of boys to girls in the 6th grade is 10 to 15. If there are 24 boys, how many girls are there? So we can set this up in equivalent ratio form. So I'm going to put the number of boys in our numerator and the number of girls in the denominator. And we said that was 10 to 15. And we want to know if there are 24 boys, how many girls are there? So I notice that I cannot multiply 10 by any whole number to make 24. So I'm going to try simplifying our ratio to lower terms. And I notice both numbers are divisible by 5. And notice I'm keeping the 10 in the numerator, the 15 in the denominator here. So the boys are always on the top, girls are always on the bottom of this fraction or ratio. So our simplified ratio is 2 to 3. Now I can try to make an equivalent ratio with 24 as the number of boys, and I notice that 2 times 12 gives us 24, so 3 times 12 would give us the number that we need in our denominator to make those ratios equal, and that's 36. So that means there are 36 girls. Number 2. The ratio of marbles to stones in a large pot is 6 to 7. If there are 42 marbles, then how many stones are there? So this is really important to set up your ratio either in fraction form or in, I'll show you what the ratio as well, but you want to label it. So I'm just going to use the first initial M for marbles, S for stones, and the marbles is 6, the stones is 7. And we're told there are 42 marbles, so I'm going to match that up in the numerator of our equivalent fraction or equivalent ratio. And I know 6 times 7 gives us 72, so that means 7 times 7 would give us the number of stones in that pot. That's 49. So 49 stones in the pot. Now, if you're setting it up in ratio form, that's okay too, right? Make sure that you're labeling what's what. So marbles is 6, stones is 7. And again, we're told there are 42 marbles. That's our first number. We don't know what the second number is going to be. So now I'm working from the top to the bottom. 6 times 7 is 42. So 7 times 7 would give us our missing number of 49. All right, on to number 3. The ratio of dimes to quarters in a bag is 9 to 24. If there are a total of 24 dimes, then how many quarters are there? And again, I'm going to label everything. We can set it up in fraction form, dimes and quarters. My dimes is 9, quarters is 24. And we're told there are 24 dimes. And again, there's no whole number that I can multiply 9 by to make 24. So I'm going to try simplifying 9 over 24 to lower terms, and then we'll see if we can make an equivalent ratio. So 9 and 24 are both divisible by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. So that's the lowest terms, and we want to make an equivalent ratio of 24 in the numerator. So 3 times 8 gives us 24. So we would have to do 8 times 8 to make that equivalent ratio. So it's going to be 64 in our denominator. So 64 quarters are in the bag. Number 4. The ratio of trucks to cars is 14 to 16. There are a total of 21 trucks. How many cars are there? So again, I want to label. I'm going to put trucks in the numerator, cars in the denominator. And already I can see I can't multiply 14 by any number to make 21. So we're going to have to simplify 14 over 16 to lower terms. Both of those numbers are divisible by 2. 14 divided by 2 is 7, and 16 divided by 2 is 8. Now I can set up an equivalent ratio here, and I notice that 7 times 3 gives us 21, so 8 times 3 would give us that missing number of cars. That's 24. So 24 cars. Number 5, the ratio of red ribbons to green ribbons is 4 to 6. If there are a total of 32 red ribbons, then how many green ribbons are there? So I'm going to set this up as red in the numerator, green in the denominator, 4 over 6. and there are 32 red ribbons. We're going to put that in the numerator. I know that 4 times 8 gives us 32, so to make an equivalent ratio, we have to multiply 6 times 8 as well, and that would be 48. So there are 48 green ribbons. Now notice I am writing out the answer here on the side. The final answer is not writing it in ratio form or fraction form. You should write out there are 48 green ribbons. And our last question here, number 6, a chocolate muffin recipe requires 1½ tablespoons of baking powder for every 2½ cups of flour. If 12½ cups of flour are used, how many tablespoons of baking powder are needed? So I'm going to set up here a ratio table, and I'm going to label BP for baking powder and F for flour. And I know there, based on the problem here, we have, 1½ tablespoons of baking powder for every 2½ cups of flour. And I'm going to move through our ratio table and skip counts by 1½ for the baking powder and by 2½ for the flour. Since we know we're using 12½ cups of flour, I'm going to start by skip counting my flour until I get to 12½. Then I know I can stop. So if I add 2½ here, that would get us to 5 for the next entry. If I add another 2½, that's going to get us to 7½. Adding another 2½ gets us to 10 cups of flour. And then we're going to add another 2½ here. That gets us to our 12½ cups of flour that we have. And now we're going to do the same thing for our baking powder. I'm going to add 1½ every time, skip count. So our next entry is 3. And then if we add another 1½, that would be 4½. If I add another 1½ here, that would be 6. And again, I'm going to add another 1½ here to make 7½. So that means we're using 7½ tablespoons of baking powder for the recipe. All right, if you have any questions, please ask in our Google Meet or message me directly. See you soon. Bye-bye.